Okay, movie time! Movie time! Okay, so I wanted to go over our chapter 27 stuff that we did not get to do before we finish. So, very quickly, chapter 27 is about doing t-tests for slopes and a t-interval for slopes. So it's basically when you go back to our old unit on linear regression. Hey, remember for linear regression unit, you have bivariate data. Remember that's what it's called. It's when you have an x and a y, right? And we would normally graph our points, right? Your x variable here, all the stuff you already know, your y variable here, and we would graph our points, right? And we would then use our calculator or technology and get your line of best fit. Remember, that's called your least squares regression line. Good little review for you. Least squares regression line. So basically, we're going to now do a confidence interval for the slope. So like, we're going to get some slope from our technology, right? Whatever that slope is, but we want to show that it is, that we understand that the true slope of the population might not be what we get from our sample, right? Just like when you get a sample of a GPA out there in the world, it might be the real GPA of all Westland High School students because it's only from a sample of 20 Westland High School students. This is the same thing. This might be the real slope, but it probably isn't. So we understand that the slope will be in a range of, and so that is our confidence interval. So we're going to start with that, and then we'll go to the test. So for the confidence interval for slope, it's called a t-interval for slope. Okay. Beta represents the true slope of the population, right? We don't know what that is. All we know is our slope of our sample and our linear regression line. We don't know, right, the true answer, the true slope of the population. So that's what we're trying to express. So we're trying to express what beta is. Well, beta will be whatever our slope is. B, I think we called it B1. You could call it M, whatever you want. So there's your slope, plus or minus your T critical times your standard error of your slope. So remember, this is no different than any confidence interval we've done. This is your sample slope. We call that, remember, point estimate. Point estimate. I do not like that the parentheses looks like a C. That's bothering me. So we're going to take that out. Okay. So that is your point estimate. And then this represents, remember, altogether, this is your margin of error. So what the heck is the standard error for slope, right? Like, what is that? Okay, there's a formula for it, you guys. I don't think you're ever going to use it, but I'll give it to you. I just don't think we're ever going to have to use it. So the formula for the standard error of the slope is the standard deviation of your residuals, which is just S, divided by the standard deviation of your x variables times the square root. I just forgot what it was. It was the square root. Oh, is it -1 or -2? Let me make sure I'm right on this. I don't want to mess up, you guys. Don't want to mess up. So let me make sure I give you the right number. n minus 1. N minus 1. We typically never do it. The fact that I'm looking it up tells you that we'd never do it by hand. So don't stress too hard. You probably won't use the formula. So this is the standard deviation of the residuals. You might have forgotten what a residual is. I will show you again on the graph. And then this is the standard deviation of just the x variables. And then this is your sample size. So that will give you the standard error of the slope. Okay, I'm going to be honest though. They're going to give you printouts on these. We don't do a lot of calculator on these. They give us printouts. Way back when we were in that unit on linear regression, remember I told you there was other stuff on the printout that we didn't need to know? Well, now we're going to look at that stuff and we're going to need to know it. So remember what a residual is? Residual is the distance from the point, right, to the line of best fit. That distance from there to there, remember, is called a residual. Okay, right? Residual was always observed minus predicted. Remember, your line of best fit always tells you, and we use an E, because remember, we can't use R because R is correlation. So they sometimes use an E symbol. So observed minus predicted is your residual. Okay. Remember, we have a bunch of residuals because all of our points vary around our line. Okay. So that will be your standard error. Again, you're not going to probably calculate it. And then T critical. Well, how the heck do I figure out what T critical will be? T critical will come from the confidence level and your degrees of freedom. So T critical will come from confidence level, so they'll have to tell you how confident they want to be, and your degrees of freedom. So again, the degrees of freedom on these problems, unlike any of the other problems we've done, degrees of freedom on linear regression problems are sample size minus 2. Sample size minus 2. Different, right? Different than anything else we've done, okay? So remember chi-squared test, it was number of things minus 1 or number of rows minus 1 times columns minus 1. And in the t-sample tests for means, it was always degrees of freedom minus 1, except for that weird formula when we had 2 groups. So this is a different one. It's an n minus 2, and it's different than all the other ones. So that's it. That's all you got to do. Okay, now, I didn't even talk about conditions, right? So that's all you do for the formula. What are the conditions for running any of these things? T-test for slope, T-interval slope. Okay, here are your conditions. Your conditions are, you need to have a random sample. Or you did random assignment. I don't know if you did an experiment, but you probably didn't do an experiment. Most of this is probably a sample. And then N is less than 10%. This is to help have independence of population, size, and then here's the new ones. The scatter plot should look linear. Scatter plot, I was going to write scatter plot plot. What am I thinking? Scatter plot looks linear. And the residual plot also looks linear. This is for the same thing. The residual plot, remember, has no pattern. Remember, when it has patterns, we're looking for that curved pattern on the residual plot. So that's all sort of that third condition, which is only for these, right? We've never had a condition like that. And then the only other thing we talk about is, this is a weird one, is the residuals are normally distributed, which means you probably should look at, if you'd have the data. If you don't have the data, you don't have to do this. So you should probably look at a histogram of the residuals. And you would like that histogram to look, you'd like that histogram of your residuals. Now you're going to have negatives and positives because some residuals will be lower than the prediction line, some will be above. So you'd like it to look, you might have some gaps, but for the most part, you want it to look fairly normal, okay? You don't want to see a skew, you don't want to see outliers. Now, if your sample size is greater than 30, just like t-test for means, you're okay. So see, if they pick a sample bigger than 30 and they have more than 30 dots on your thing, then you don't have to really worry about checking number 4. So you prefer that. But I'm going to be honest with you. On these problems, they tend to tell you that the conditions have been met. Okay? Tends to be on these problems. They always tell you the conditions are met. You don't have to worry about them that much. But these two you're used to, right? But 3 and 4 you have not had to do. But we did do back in that linear regression stuff. We did do, like, you had to look at the scatter plot and say it looks like it's a line pattern. You're still doing that same thing. You're saying, hey, it looks like a line. The dots look like they're a linear pattern. Okay, and the residual has no pattern, which means linear model is a good fit. Okay, so that's just sort of what we did way back then. They have this new one about residuals being normally distributed. That's a new one. Okay, but there are your conditions. Everything else is the same, you guys. Interpreting the interval, I'll do one with you. We'll interpret it. But remember, on an interval, you're just going to do the conditions if you have to, and then you're going to calculate the t-interval. And it's going to tell you what we think the true slope is of the regression line. So let's do one. I have some data for you. The scatter plot displays the data in how long we had the duration of the next eruption of Old Faithful, and in July of 2019, and the y-axis tells you how long you had to wait for the next eruption. So how long was the eruption, and then how long we had to wait. Here's the scatter plot. Okay, I'd like you to calculate a 95% confidence interval. So I want you to calculate a 95% confidence interval. Okay, so our 95% confidence interval. First thing we need to do, check conditions. They did not say anything about conditions have been met. So I don't have all the dots. I don't know what they all are exactly, so I can't really check. But we do have 25. So on my conditions, well, they said it was hopefully a random sample. Oh, they said it. Random sample. So it was a random sample of Old Faithful eruptions. And 25 is less than 10% of all the eruptions that Old Faithful has. So that's okay. So those are no different, right? We've been doing those since chapter 23 and 22 and even the earlier ones. Okay, this is the new one, scatter plot. So I look at the scatter plot. I don't have the residuals and I don't have the residual plot. So I look at the scatter plot, mostly linear. Okay, it looks pretty linear. Scatter plot looks linear. We also like to see, this is something I'm going to point out on this graph, we also would like to see that the spread of the residuals is pretty consistent. So you're not having like the fan pattern happening. Okay, so that's also something we don't want to see happen. We want to see the spread stay about the same. I know they all don't fit the line super, this is not a really high correlation, but I don't think there's a curved pattern going on. So scatter plot looks linear for the most part, right? We don't have the residual plot, so we don't have to comment on it. And then since the sample size is 25, I assume the residuals are normally distributed. It's a fairly big sample. So we're probably okay on that. Okay, so now it's time to calculate the interval. Okay, so I'm going to do it by hand because they gave us the printout and everything's actually on the printout. So we got to remember way back in that old chapter where everything is here. Okay, slope. Slope, remember, is the coefficient that's with your x variable. So the x variable in this problem is the duration of the eruption. So this is your slope. So we got a slope on this printout of 7.79. So 7.79 is our point estimate. That's the slope that we got from our line of best fit. Okay, the next thing is we need to get the T critical. So T critical we'll come back to. And then the last part is the standard error. Here's what I wanted to show you that we ignored before. Oh my gosh, you're going to be so excited. Look, the standard error of the slope is the one that's next to the slope. So this is the other number we need to do a confidence interval, the standard error. So that's why I told you, you're probably never going to have to use that formula. They probably already did it for you when they gave you the printout. So that is the answer to that formula. They have already done it, okay?
I like it a lot.
That's right, okay? So the printout is amazing. You use that number, so that is going to be 4.03 right there. That's your number, okay? That's it. See, you don't do any calculation, nothing. So now we just need to do our T critical. Well, we have 95% confidence, and we have degrees of freedom are 23, right? Because I did 25 minus 2. So we're going to open our T table. I forgot to leave it open. Go back to chapter, hurry, hurry, hurry. Chapter 19, no, not 19, 20. Yeah, 19, I gave it to you in 19. T table. Okay. So here's your T table. So we got 23 degrees of freedom, 95% accuracy. So 95%, 23 degrees. I think it's that number right there. So that gives me 2.069. So T critical is 2.069. And that is it. So here's the thing. If this is a multiple choice problem, I love these multiple choice problems because you just have to pick that out and you're done. That is it. So really the only number you're really trying to figure out on multiple choice is the T critical, right? You're trying to figure out the T critical. So because this is on the printout, this is on the printout. As long as you can read the printout, you should be good on that. So these two are on the printout as long as you can find them. And then this is one thing we have to look up in that table. That is it. That's all we have to do for t-test, t interval for slope. So there we go, 2.069 times 4.03. I get 8.33 right there. And then I take that 8.33, add a 7.79, plus that answer and 7.79 minus that answer. So it looks like my interval goes from negative 0.54, I'm sad right now, you're going to see why in a second, 8 to positive 16.13. So there is our interval. We did critical, choose standard deviations basically, times the standard error, plus or minus. So there's your interval. Okay, so that's the answer for the mechanics. Interpretation. You guys, I don't care that we're doing something else. I don't care that it's still the same kind of interpretation. So you say how confident you are. I am 95% confident. I should like record this so I don't have to read it over and over again. That the true population slope for Old Faithful, putting in my context here, wait time versus eruption length duration is between negative 0.548 and 16.13. That is the slope, which means our slope could be negative, our real slope could be negative, or it could be positive. So that means that we got a positive on ours, but the real one could have been negative. Very slightly negative, but still a negative, right? It was negative 0.54. So it could be a slight negative, or it could be a positive, right? We don't know. We don't know. So here's the bad thing. The bad thing is, because it could have been negative to positive, that means it could be 0. And if the slope is 0, that would mean we could have no slope at all. So we could have no relationship at all. Because remember, if the slope is 0, that means as you increase x, y doesn't do anything. So if you get a slope of 0 in your confidence interval, that could mean there's no relationship. Right?
Once again, things that could have been brought to my attention yesterday!
Okay, so that's what that's going to lead you into the test, the hypothesis test. So 0 is in the interval, which might indicate there's no relationship. All that work, and there might not be a true relationship. So that's a little weird. Now you're looking at linear regression in a whole different light. Because before, you guys would do linear regression and you'd be like, oh, there's my slope. There's my line of best fit. I did all the math. It's perfect. There's my line of best fit. Not thinking about, remember, this is just your line of best fit from your sample. And when you do another sample, it's going to change. And you're going to get a different line of best fit. And then your friend's going to do another sample, and it's going to be different too. And then they're going to get another line of best fit. So we're all going to have these different lines of best fit. Well, the confidence interval tells you where we think the true slope is for the line of best fit. Crazy. It's crazy that you can do that. Okay? It makes me want to go analyze all those old problems differently now, because it's so crazy. So that's it for your interval. That is all you're doing. Probably on the AP exam, they will give you the printout and you will just maybe, multiple choice, I'm thinking maybe you might have to pick out the formula right here, maybe. FRQ, basically FRQ would go through just like we did here. Conditions, write your interval, interpret. Notice I'm not running to my calculator because really there is nothing on your calculator to do this, okay? Yeah, it's really all my 6 years of doing AP stats, we don't run to our calculator for linear regression. Only if they give you all the data and you want to actually get the line of best fit, like you're trying to get the line of best fit. But that's still not going to give you the standard error. So, right, to get standard error, you need to calculate more things. You need to know what the standard deviation of the residual is. You need to know what the standard deviation of the x variable is, which I'm sure your calculator has somewhere, but it's probably a little harder to find. And if you look at your calculator, there is no test. There's a linear regression t-test and a linear regression t-interval. So if they do give you the data, which is rare, totally rare. So I don't like to show you this because usually you're never going to use this. But I'll show you that if you're given the data, like this is more real world. If you're in the real world and you do have an X and a Y data, and you've already went and you've already put it in your calculator, okay? If you go to stat, test, very bottom, there's a linear regression t-test and a linear regression t-interval. What does it ask you for? It asks you for where's your data, so what column did you put both your data in? What's your confidence level? And there you go, calculate it. So that's if you're given data. I'm just not given data too often. So usually it's already done for you, okay? Usually that's what happens. Okay, so there's the interval done. We're at, how many minutes have we done this video? We're at 27 minutes. Ooh, that's fairly long. I'm gonna stop it here and I'll do the t-test on a different video.